Hey guys, welcome back to the Electric Bike Lab. Today we're going to be doing a beginner style battery. So this is if you don't really have a battery to build, but instead you want to start off on something simple. We're going to be building a big power bank. So we're going to be putting some cells in here, and then we're going to be using this inverter and mounting that on the outside. And we're going to have a nice big power bank that we're going to be able to take around, charge our devices, charge some lights, fan, a cooler, something like that. Something that would be great for camping. And because it's such a simple battery layout, it's also a great way to start and to learn about lithium batteries. So what we're going to use is this ammo box is going to be what stores everything. We've got a BMS for our battery. We're going to be doing a 3S BMS lithium ion. So that's going to charge to 12.6 volts max, which is perfect for this 12 volt inverter. We've got these 3D printed cell holders. We have files you can download in the description. These allow the cells to pop in nice and easily, and they just hold them at a really perfect spacing, especially for this nickel strip that we're going to use. This is going to make the job even easier. This stuff is already 2P, so it's going to connect them together. We just have to cut it to length. So, first thing that we're going to do is we're going to populate our cell holders with the cells. So it's a 3S battery. We're doing 1, 2, 3, and then we're doing 10 of them in parallel. So we're going to get 30 amp hours out of our battery. It's going to be about 12 volt, 30 amp hours. These cells are 3,000 milliamp hours each. We're using these AEB, or Affordable E-Bikes branded Sanyo lithium ion cells, 3,000 milliamps, capacity 10 amps rated discharge current. So these are going to be able to provide plenty of power for this application. This inverter is only a 300 watt inverter. Yes, 300 watt inverter. So we're only going to be pulling about 4 amps from each of these cells, 3 to 4. So that shouldn't be a problem at all. So we'll get these all populated up. And so when we're thinking about a pack like this, this is a odd series battery pack. So you have 3, the number 3 is odd. So whenever it's odd, the positive and the negative are going to be on opposite sides. So this would say be positive, and then the other side would be negative. Anytime it's even, they're going to be on the same side. So what we're going to do is add some flaps to solder on, but let's not get ahead of ourselves. We'll get these in there. Okay, so we've got our cells all laid out. And if you think about a 3S battery, you're going to think of maybe you have a remote control at home for your living room, and it's got cells that look like this. This is basically what we're going to be doing. So we're going to be having folds at these 3 points, and we're going to go from one to the next to the next. So basically that same layout, except we've spread it out into this form factor. So first thing that we're going to do, we're going to get some nickel, and we're going to cut it to length. You can see this is the perfect size for this nickel. We're going to cut out a few pieces and get it ready. So we need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, and we only need 4 of these pieces total, which will include our positive and negative. Okay, awesome. So we're going to be using this spot welder. This is a newer model from Sequer. We've got a review video coming out about it you can check out. Probably will be live by the time that you look at it. It's the Sequer SQ SW3. It's a very powerful portable spot welding unit. Doesn't need a secondary power source like a battery, like a lot of the popular ones like K-Weld need. It's got a capacitive bank built in, and it charges up with a power source right here, and it's a pretty fast charge up speed. So this thing is 15 amps, which is pretty impressive. So this only takes about 5 minutes to fully charge up from being dead. And it comes with this nice welding unit. Obviously you don't need a nice spot welder. This is actually fairly economical, around 200 something US dollars, but you can get by with a cheaper one. Important to note though is that if you're going to use a lower cost spot welder, be sure to use nickel plated steel, as you won't be able to weld pure nickel with a lower cost spot welder. This will handle it no problem, so we're going to be doing that. So we're going to lay these out and we're going to map out our battery. So it looks like we're going to make this our positive. This is going to be our positive. This is connecting. And we're going to do one tab so that we'll have somewhere to weld or to solder our balance leads. So we're going to start, we're just going to get these tacked up in place. Okay, one. Do the same here. So we're going to be using this as the area for our positive, and then we're going to use this part as the flap that we're going to solder a wire to, and that's going to act as our positive area for our wire to sit. So we'll get this tacked up in place as well. So make sure we have positive, and then our negative is going to be right here. So we want to make sure at this point that we don't cross these at the wrong spot. So we're going to place this guy right here. We're going to cut off our lead. Usually we want our balance lead tab to be on the negative, just a little bit safer that way. Finally, our last one right here. So there is our area that we're going to solder the negative. This is our area that we're going to solder the positive. And we're going to put our BMS probably right here. It's going to sit over to the side a little bit. We're going to have it soldered there. Next thing we're going to do is we're going to wrap this whole battery up in Kapton tape. Kapton tape is a protective film that is very high temperature resistant and also has a very high dielectric resistance. Now we're going to go back and do our second and third weld on these points just to make sure that our welds are very strong. One. This thing produces some good sparks. No wonder Justin calls it Sparky. Okay. Now we'll just do our last couple layers of Kapton. We can also Kapton this whole area, since we won't be needing exposure to it. Okay, so the whole pack is wrapped now in Kapton tape. Let's do a quick little voltage test just to make sure that our pack is where we expect it to be. These cells should be around 3.5 cells or volts per cell, so we should be seeing around 10.5 volts right now. 10.59. Perfect. So these little leads are the areas that we're going to solder our balance leads to. So we're just going to get a marker and write down which one each is, just so we're not confused. Here is negative. So right here we're going to write negative, which is going to be our first wire. We got number 1. This is wire number 2, number 3, and number 4. Pretty easy on these 12-volt batteries when there's only 4 leads. Okay, so what we're going to do is we're going to connect these balance leads. We got wire number 1, 2, 3, 4. We've got our negative part of our battery, which this wire is going to connect to. So we're going to solder that down in place. And then we've got, this is going to be our output cable negative, and our positive output cable is going to be right here. So first thing we'll do is we're just going to glue this BMS in place. And this BMS has a temperature sensor. So before we get too carried away, we're going to install the temperature sensor. And basically, we're making a small slit so that we have direct access to the cells. We're going to put the sensor deep inside because we want it pressing right up against the cell. I'm going to hold that down in place. And then from there, we can use another layer of Kapton to seal it off. Want it as deep as possible. And then we will just make this wire a little neater. We're going to do our balance leads first. So we're going to, you can use a two-sided sticky tape. Basically, we want to lay these leads down so that it's very easy to see what the next lead is. In this case, we're just going to glue them down. So we've got hot glue. We're gluing right on top of our Kapton. Our Kapton is very temperature resistant, so this will work well. And let that dry. Okay, and the first one, we can do the same here. I'm going to cut off the excessive length we don't need. And we're going to add some solder points. So add 4 solder points. 1, 2, 3, 4. Our first wire is going right here. So we have a crossover right here. So what we do at every crossover is we're just going to make sure there's an extra layer of insulation. Before we cross over. And then we're going to cut that to length. This is our first going to the negative. And once that is crossed over, we're going to tape it down again, just so it can't move. Wire number 2 comes right here. No crossover here. So you don't have to worry about that extra layer of Kapton. A little bit of flux. That one's installed. Number 3 is crossing over. So we're going to add the crossover layer Kapton. Cross over here, cut to length. And hold it down. The final wire is coming right here. This is wire number 4 going right to the positive. And that's it. Those 4 are done. We'll add a couple layers of Kapton just to seal and secure everything down. If you had a bigger battery and you wanted to make sure that all the leads were in the proper place, you could unplug the balance lead and then you could insert a multimeter into these pins. And from negative, moving over one at a time, and you should see a growing voltage every time. So for example, from 1 to 2, you'd have 3.5, 1 to 3, you'd have 7, 1 to and so on and so forth. You'd want to see that increase every time, and then you know that you've done it properly. Next thing we're going to do is connect our battery negative. Right here, we're going to try to solder across a few points just to make sure that we're getting a pretty good connection. This is 10 gauge, so this is huge wiring. That's okay. So what we're going to do to make this a little bit easier is we're going to add some solder points. This will be connecting at least across 3 points here. 1, 2, 3, 4. So we will pre-tin the area. So add a little bit of solder beforehand. Don't worry, you've got Kapton tape underneath, so you don't have to worry about it melting through. Add some flux to this wire. So for this big gauge wire, you want to make sure that you have a hot enough iron that it's going to be able to melt it. That's going to be very important. I'm going to strip just a little bit more. What I like to do is get the first one in place. And I like to hold it down with something that's not going to burn my hands. And then just get the first bit in place. And then at least it is stuck. And from there, I like to go to the spot and use this balling method where you just tap the solder so that it doesn't get too high of a temperature. And then again, hold it in place to flatten it and allow it to cool and re-solidify. And then I'll go across to all the points and do that. So our next point is right here. I'm just going to tap it like a ball. You're trying to get a lot of material there, but not have it sink through and not burn out all of the flux that's inside of the solder itself. So now that's ready. Our iron is still high. We'll hold it down, and now it's going to bond with our solder that's underneath. Make sure it's cooled. Good. Go to spot number 3. Push down and hold. And then our final one is going to be right here. We just want this to touch. Once I'm comfortable that I have gotten this wire down nicely, I like to just shoot a layer of glue over top of it to seal it in. Any hot glue will work, even dollar store hot glue. This is just black colored hot glue, so it just looks fancy. It's also quite good stuff though. And then we can go over top of the negative so that it is no longer exposed. Good. And we're ready to solder our positive. So this is going to be our negative power wire. This is going to be our positive. 10 gauge is probably a little bit overkill, but because this is already 10 gauge, we're only going to see a max of really 30 to 40 amps, which we can do 10, but 12 would be fine. So let's do same thing. We're going to solder in 4 areas towards the middle, and in positive we're going to add just a couple extra layers of Kapton, just because if it burns through, then the negative of the cell is right here. So just to be extra careful, especially with this heavier gauge wire. So we got 1, 2, 3, 4. It's going to be about this much. Strip half of it, and the other half. a good amount. Whenever the wire becomes a little bit hard to tame, I will just keep squeezing it and twisting it, and then I will just solder the end just to keep it all together. That seems to work pretty well, and then I'm just going to get it stuck in place at first. So now it's on. I'm going to grab my tool. I'm going to try to get it a little bit further down. Good. Okay, number one. Number two, we're going to ball it all up. Hold it down. You want your pressure to be with the pliers, not with the iron. You don't want to push down on the iron. At this point, we've got positive and negative. I want to cross them. So I'm going to do the same thing. I'm going to glue over top of this whole area. Not a bad idea at this point to run a layer of fish paper right after you add your silicone. You can run it underneath as well. So we're going to do that. Just you don't have to use this stuff, fish paper, but it is it's good for abrasion resistance. If you don't have it and you don't want to use it, you can just use lots of Kapton. That's going to be just fine. The glue will just really keep anything from oxidizing. It will help with vibration resistance, and it's a layer of insulation, sealant. I'm just going to add this here. Okay, now we're going to turn this into an XT connector. So I'm going to chop this off, strip back just a bit. Solder in negative. I like to use a mini vise to hold the connector. And of course, some heat shrink to go over top. And we're going to be connecting a charge port at the same time. Here's our little charge port. We're going to have that run through. I'm going to pre-tin with solder our negative part here. I'm going to add some here. Then I'm going to throw the negative into the XT60. My iron is on high, and it should only take about a second to melt in place. I'm also going to add the charge port connection at the same time. Add a tiny bit more solder. And then shrink that over. So our negative is done. I'm going to flip around my vise so that positive faces up. I'm going to strip a little bit of the positive wire, pre-tin it, feed positive of each through it, throw this right in. Then add the positive charge wire at the same time. and heat shrink. Okay, at this point we have a functioning battery. So we're going to wrap it up and seal it up. And we've got our connection points. Let's go make sure that this is giving us any voltage. I'll go grab the multimeter. Good, so it is working. We got 10.6 volts coming through. So the next thing we're going to do is seal this battery up. So I like to use fish paper, which is this stuff right here. It's very good for abrasion resistance. So a layer on the nickel, a layer here, and one layer just around. We'll do that, and then we're going to do a layer of heat shrink, blue heat shrink. So in this case, these are both 8 inches long, 65 millimeters or 2.5 inches wide, and then one layer going all around. That's going to be about 21 inches. Our cable exit is right here. From here we're going to get some heat shrink. So this is 80 high by 70, so 150 millimeter heat shrink would be ideal. So because you're going to see the green on the sides, it's not a bad idea to put something a little bit more waterproof on the sides. You could do something like electrical tape. We use a fiberglass tape which holds a nice seal. So we're going to add just a little bit of that. Even Kapton tape, which we could use as well, just so that when the heat shrink comes up here, you can add just a layer of glue and then you are fully sealed. One. And now we want this to overlap about 1 inch on each side. It's about all we need. And we'll start heating up the sides first. Probably a bit too long, but it should be okay. You want to go nice and even all around the pack, being sure not to hold it anywhere too long or it could rip. And then at the very end, get the end nice and hot, and then you can fold it into itself and then just hold pressure on it and it will lock in that shape. We can do the same to this side afterwards. You can see this is locked that shape in. And for this, because our cable's a little caught, we're going to give just a little relief for the cable to come out there. And we're going to do the same thing here. And at these areas, you can either add a silicone, especially right here, you can add a silicone layer. You can do something like hot glue can work, or Flex Seal. We're going to do some hot glue here. Okay, our battery is basically good to go at this point. You can add some silicone here as well, which we will do in a little bit. One thing that we want to do, though, is we want to mount this onto our box. We also want to test the fitment. We do have quite a bit of room here. And we want to drill a hole to allow this to go through. so that it can plug directly into our battery. We're going to use a watertight fitting right here after we do that. Okay. Good. Okay, so we will be using a 3D printed bracket, which we will install on a little bit later. For now, we can just hold this in place, bring out the classic glue, and then we're going to throw on an XT60 connector. So we've already determined which one is positive and negative, but the wire that came out of the right side for us was positive. When we connected it, you can connect to even like a 9-volt battery to see what side lights up. It does have a reverse voltage protection, so it just would not light up when it's in the on position when it's not hooked up correctly, and it will when it is hooked up. So something you'll have to do a quick test. Maybe yours is the same. It's the right wire. They don't have a positive negative labeling on them. Positive connection on our XT60. Now our negative. Right here. Okay, so we've got our 3D printed brackets. They're going to hold this on, and they're slightly loose, so we're just going to add some of this double-sided foam mounting tape, and that's going to close the gap and stick to it just a little bit better. So we'll add that on. Okay, so we're going to go right here so we can see. We want to see 300 watts so that we don't push this thing too far. So maybe we'll go right there. And then we'll go right here. And then we will screw in our screws. And we're hoping they just tap right through. Now we got the sharp things on the inside, so we're going to put some foam right over top of that. One. Good. Okay, so these guys are in there. And then we've got our battery that we want to also put plenty of foam in and around so that it's going to have a nice cushion. So even if you push on this foam, you don't feel the screw, which is nice. We're going to have an extra layer of foam there, and then we'll do some right here. We'll do one on the side. How much room do we have front and back? One layer of foam front and back should be good. A little hard to see, but the battery is in there and it's pretty solid. Pretty solid. not really moving. And then what we can do is plug the inverter into the battery. Oops. So that's good. And then we will plug the charger into the battery. The charger is a little loose, so we could do a couple layers of foam right here just to try to keep that in a little bit tighter. And then we want this cable to be accessible. Okay. It's kind of a look. Let's see if it works. All right. So first we'll see if, look at that. We have charging. Okay, that's no problem. Let's try something a little crazier. This is 300 watts. So this is kind of a perfect test to see if we can get it to work. Ready? 3, 2, 1. This is nominal voltage, so it tells us when it's getting a little bit low, but it works and it's hot. We should charge this up to full. At least it warns us when it's getting low. Okay, we understand. Then we plug it into charge. Awesome. Well, I think that's a success. Well, there it is, guys. It is a completed project. It is a portable power bank that you can bring anywhere with you, and it's got quite a bit of capacity. This is about 300 watt hours. So if you've made it this far, that's awesome, because we are giving away 2 of these to somebody in our audience. And what we want you to do is, if you've made it this far, which is pretty awesome, include the word cauliflower in your comment and let us know why something like this would be handy for you and why you'd like to be able to build something like this. Because we're going to give away 2 kits, complete kits. So that's going to be the ammo box, the inverter, all of the cells, the BMS, and all the little heat shrinks and tapes and whatnot that are required to build this. We're giving away 2 of those kits as part of our subscriber giveaways. So if you did like it, please make sure to drop a comment. Thank you guys so much for watching. We really hope you enjoyed it, and we'll see you in the next one. Keep it on 2 wheels. Thank you guys so much for watching this video. Make sure to drop a comment. Let us know what you think. Let us know what you'd like to see. We want to hear about it. And if you want to watch another video, click on this one right here. Or if you want to see what kind of e-bike stuff that we've got, check out this link right here.